Today we're going to look at angles at a point. Angles can be classified according to their size. An acute angle is between 0 and 90 degrees. So it's less than a right angle. A right angle is 90 degrees. This angle here looks less than a right angle. 90 degrees is a corner. So this angle here looks to be acute. Obtuse angles are between 90 degrees and 180 degrees. A straight angle is one that is a straight line, it is flat, it's 180 degrees. A reflex angle is then larger than that, between 180 and 360 degrees, and a full revolution moving around in one circle is 360 degrees. We can name angles using the following different conventions. This symbol at the front here is an angle symbol, so we might name this angle ABC, or angle CBA, or just angle B, or B degrees there, naming that angle. Note that when we're naming it ABC or CBA, the B, the angle where the point actually is, where the two lines meet, is in the middle. So the point B, this vertex here, is given as the value that's in the middle of our naming convention here. So we can have special angles at a point, but I'm just going to show you for 1 second how we can measure an angle. So if you've got a protractor, what you need to do is you line the line up one line with the base of your protractor here and the center of your protractor at the vertex, at the point that you want to measure the angle at. So when that's lined up very nice and precisely, we should be able to then read as we go from 0, 10, 20, 30, 40, 50, just how large this angle is. So if I was doing this nice and accurately, I'd be seeing that this angle is just under 60 degrees, probably about 59 degrees or so. And so we can confirm that that angle is indeed acute. So now looking at special angles at a point, there are different kinds of ways that we can classify pairs of angles. We can have a look at complementary angles. Complementary angles add to 90 degrees. So we've got here our angles A and B here. Those two angles add to 90 degrees. So those angles A and B are complementary. If we have to determine an angle, say we knew that A was 30 degrees or so, we would be able to determine B because we know that those two add together to get 90 degrees. Here we can use a little coded symbol, a little coded reason there, if we use that when we're trying to work out and solve a problem involving angles at a point. So if we know that we need to have a look at some complementary angles, we can use this little symbol here. Supplementary angles sum to 180 degrees. So if we've got any straight line, any of the angles on that line, they will all add to 180 degrees, and we can use this coded reason here that shows that. So for example, we've got a straight line here, so C and D are supplementary angles. They add to 180 degrees. We also know that vertically opposite angles are equal. So two angles that are equal in this situation are A and C. A and C are equal because we've got two lines that cross, they intersect at this point here, and because they are vertically opposite each other, we know that they must be equal. Also, angles in a revolution sum to 360 degrees. So if I was to add A plus B plus C plus D plus 90, adding all of those angles together, because it's one revolution all the way around, adding all of those angles together would get 360 degrees. So these two lines here, they're at right angles. This is the symbol we use for showing that they're at right angles. So this is 90 degrees here, 90 degrees. That's a right angle there. We've got here, if we're having a look at our classifications, B and A are both acute. They've both got to be less than 90 degrees because they add up to 90 degrees. C is also going to be acute because A is. And D here looks larger than 90 degrees. So I would say that D is an obtuse angle. Now, if we've got two lines that meet, that intersect, at 90 degrees, we can call them perpendicular. So those two lines are perpendicular. Here we've got a few examples for us to look at. So we're being asked to determine the value of the pronumerals in these diagrams. First diagram here, we've got two pronumerals that we need to find A and B. Our first one, A here, we can see is part of a 90-degree angle. This 90-degree angle has been split into A degrees and 30 degrees. So we know, using this coded reason here, that these two angles must be complementary. They sum to 90 degrees. So A plus 30 is 90. A plus 30 is 90. This whole angle through here is 90 degrees. So in order for that to be true, A must be 60 degrees. So when we're looking at B, B is the remainder of moving all the way around in a revolution from this point, subtracting away our 90 degrees here. So if I have 90 degrees plus B, that's going to be 360 degrees as it goes all the way around in one revolution. So we can use the revolution coded reason here to determine that B is 270 degrees, because B plus 90 must be 360 going all the way around. In our second diagram here, we've got two lines that intersect at a point, and we know that along this line here, that angle all the way along there is a straight angle. It must be 180 degrees. So these two angles here must be supplementary. They must add to 180 degrees. So we can use the supplementary coded reason here to say that A plus 65 must equal 180 degrees. So in order for that to be true, A has to be 115. We know that B must be 65 degrees as well, because it is vertically opposite. We can use the vertically opposite coded reason here to show that because they're vertically opposite, B must be the same as the angle opposite it, and the angle opposite it is 65 degrees.